Hello everyone, welcome back to Coding Intuition. Today we are going to solve count unreachable pair of nodes and an undirected graph question on LeetCode. So let us first understand this question. So in this question we are given edges of a disjoint graph and we need to identify how many pairs each node inside a disjoint graph can make with other disjoint graph. For example, if we consider a second example here, where here in the first disjoint graph we have four nodes and we have a graph which have one node and we have a graph which have two nodes. So basically we need to find out how many total pairs uh, they can form with other graphs. For example, if we consider this first graph, it has four nodes. So how many pairs it will form with this one? It will form four pairs. Okay, and how many pairs it will form with this second graph? It will form two pairs for each node. So basically 4 into 2 is equal to 8, so it will create 8 plus 4. And how many pairs will these two create with each other? These two will create two more pair with each other, 3 1 and 3 6, so which becomes 8 plus 4 plus 2 14, which is the answer in this case, 14. So that is what we need to do in this question. We are given edges of undirected um, uh, disconnected graph, and we need to find out how many total pairs their nodes can form with each other. These many total pairs their nodes will form with each other. Okay, and in first example we can see there is only a single graph, so only a single disjoint graph. There is no other connection, another separate graph in this, so that is why it will create no pairs. It will return zero only. So that is what the question is. Now let us jump to the whiteboard and try to understand it, intuition behind it and solution behind it. So as this is a graph question, so first most intuitive approach comes in the mind is to traverse the graph. And to traverse the graph, we can either use depth first search or that breadth first search. They both will be kind of similar in this case. So I will only be explaining depth first search here, and after this I will also explain the union find algorithm, which can also be used to solve this question. So let us just first understand how we can solve this question by using depth first search algorithm. So in this question, what we will be doing is, firstly we will create an adjacency list, obviously. So as we have these edges given, we will create an adjacency list in which we will store. Okay, so 0 is connected to 1 and 2, and 3 is connected to 1, and so on. That's how we will and create an adjacency list first. So after we have created an adjacency list, we will run that first search multiple times until we cover all of our disconnected graphs. So basically what we will be doing is we will be running a loop from 0 to n is 10 in this case, from 0 to 10 in this case. And for every node we will be checking if it is not visited, we will run a depth first search over it. So for example, let us just start doing it by the node number 0. We will run a loop from starting from 0. So we will firstly run that first search over 0 and try to find out how many total number of nodes are there in it. So after running the depth first search, it is basically we just need to increment and counter, and we and when the depth first search is completed, we will have total number of nodes inside this disconnected graph. So as we run our algorithm, we will have that. So we have 1 2 3 4 nodes in this. Okay, so we have four nodes in this graph. Now we will do the same again and again. So we will now move to 2, second will now move to 1, then to 2. So when we go to 1, we will check it is already visited in our visited array. We will mark each and every node visited as we visited. So we'll mark 1 visited, and 1 2 and 3 will already be marked visited, as in this depth first search they are already covered. So now we will move to 4, and then we will do that first search again. So we will do depth first search again and mark 4 and 8 to be covered, and so on. We will keep doing that, and each time we are doing the depth first search, we will calculate how many total number of nodes are there in each disconnected graph. Okay, so here we will have four nodes in this, two nodes and sorry, two nodes in this and three nodes inside this. So that is what we will calculate by using that first search first, and one node in this disconnected graph. Okay, so as soon as we have we get all these things, we get all total number of nodes in current graph, we will apply a simple formula inside our loop itself that states that, for example, let us consider how many pairs will be formed between this graph and this 9 graph. So it is as simple as that. Each node will form a pair with 9, so it will be 4 into 1 9. And now let us consider another example. How many pairs will it be forming with this graph, with the two nodes? So it has four nodes, and each node will form a pair with 4, and each node will form a pair with 8. So that's how we will form 4 into 2 8 pairs, as simple as that. So what we need to do, as soon as we calculate total number of elements in our first graph, we will say that the number of pairs this graph will be making with all other with all other nodes inside this disconnected graph. So this disconnected graph will be making 4 into uh, remaining nodes will be for now all nodes are remaining, 10 nodes are remaining for us. So 10 remaining nodes minus nodes in current graph, which is basically 4, and remaining node are 10 for in this case. So 10 minus 4 will be equal to 6. So and 6 into 4, as we have done in all other cases. So these are 6 nodes, 2, 3 and 1. So these are 6 nodes and these are 4 nodes. So 6 into 4, yeah, that means 24. uh, uh, it will be making 24 in this case, as we can see here. So it will be making 24 pairs in this case for the first graph. Okay, so this will make 24 pairs. Now we will, when we will move to 4, uh, here, so in that case we will update our remaining nodes to 6. As we have consumed 4 nodes, we are remaining with the 6 nodes. Now we will again update our remaining nodes to 6 minus 2 is equal to 4. So we have again consumed 4 and 8, and we have calculated already. I have told you we will calculate these numbers from that first search. 6 minus 2 becomes 4. So we will add to our answer 24 plus 4 into 2. Basically 4 is the remaining nodes. We have remaining with 7, 5, 6 and 9, which is equal to 4 nodes. So, and current graph has 2 nodes. So basically this will be making 4 into 2 6 pairs with all these nodes, all these remaining nodes. And we are not calculating with this because this one is already calculated. When we have calculated for this, we have calculated it with all of them, so we don't need to calculate for this first graph. Okay, so now we have calculated. Similarly, we will do the same thing again for this one. So here we have 3 nodes inside this, and now we will be remaining with one node only, that is 9. So now 3 into 1, we will add 3 more pairs. So these 3 guys, 5, 7 and 6, will be making one pair with one pair each with 9. So that will become 3. Now 9 is remaining, there is nothing else to make pair with, so 1 minus 1 will be 0, and our answer would be 35 in this case. So that is the depth first search approach we will be going with. So let us just quickly see the code of depth first search, and then we'll try to understand it by union find algorithm as well. So now let's just quickly work through the depth first search code and try to understand it much better. So first of all, we will be creating an adjacency list, and that will be as simple as pushing that saying from we can go from 0 to 1, as well as 1 from 1 to 0. We will be creating an adjacency list, and as soon as we create an adjacency list, we will create an visited array, which will contain if the particular node is visited or not, and the size of it would be n, because we have node, for example, we have 10 nodes, and so we will be have 0 1 2 3 4 5 6 7 8 9 okay, 9 as a nodes. So now we will initialize our answer to 0, and we will run loop for all of our nodes, and we will check if it is not already visited. For example, that in the example we have seen, let us say we have a graph of nodes 0 1 2 and 3, and we will traverse that graph by firstly using that first search. And in that first search, we will pass a variable called nodes in current graph, and that we will increment by as soon as we traverse through the graph. Okay, so we will as we traverse through the graph, we will then we will set the node we are visiting to true, and we will increment the nodes in current graph by 1 every time. So that's how we will have the nodes of each graph. So as soon as we got the nodes in the first graph, we will implement that formula that we have seen just right now. The nodes in current graph and the nodes remaining in all of the graph, we will multiply both of them and add to our answer, and we will update the remaining nodes as well. And we will keep doing that until our every node in our graph is covered, and if it is already covered, it will be declined by the visited array that it is already visited, and at the end we will return our answer. So that is a simple code for that first search algorithm, and the breadth first search approach would be pretty much similar, but just we have to do it with breadth first search. So I'm not explaining that here. Now let us just move to union find algorithm and try to understand how we can solve it using union find algorithm. So now let us try to understand union by union find algorithm. So to understand union find algorithm, let us just traverse through this example and try to understand what we will be doing in union find algorithm. Okay, so as we have given these edges in this question, so let us just connect these edges and form a union first. So how we will be doing in that code, I will explain that later. So let us just explain the overview of it firstly. So firstly, we will connect the node 0 and 1. Okay, as we have given this in our input. Now we have given 0 and 2. Now we will connect node 0 and 2, and before we connect node 0 and 2, when we have connected node 0 and 1, we will decide a root amongst them. We will decide a head amongst them. Okay, so let us decide that 0 is head amongst them. Okay, now as we go ahead, uh, if we are adding the nodes in the similar graph, in the similar disconnected graph, we will keep our head to be 0 only. Okay, we will decide our head for to be 0 only for now. Okay, so now let us connect 0 into and decide our head. Our head is we decide our head again to be 0. Okay, now let us connect 1 and 3, and again in this case let us decide our head to be 0, and we will somehow store this inside a array. Okay, that the head or the root of these three four nodes, the head of 0 is 0, and head of 1 is 1, and head of 2 is 0, and head of 3 is 0. We will somehow store this in our array. Okay, now let us move ahead in the code, and now we will connect this, and we will say let us say that head or root of it is 4. So now we will do that in the array as well. So the head of 4 is 4, and the head of 8 is 8. Okay, now as soon as we have done that, we will move to next element. So we will connect 5 and 6, and we will say let's say 5 is our head now. Okay, and we have assigned it here as well. The head of 5 is 5, and head of 6 is also 5, and head of 7 will also be 5, as we will connecting them in the same graph. So the we will first so what we will be doing is we will be designing head for the elements inside the same graph. Now we are remaining with 9, so 9 will be a graph in itself, and it will be head in itself. So we will say the head of 9 is also 9. Okay, so now this is a basic explanation, and if you really want to understand how we'll be writing inside the algorithm, you can click on the I button and check the detailed video on union find algorithm. I have made a 17 or 18 minutes video to explain union find algorithm in depth, in which you can understand it from very brute force approach to its optimal optimization. That will not be possible to explain on this video. So I have just explained the basics of union find here, and in that video you can find out union find from very much depth, and that video will clear all concepts about union find. Okay, so you can click on the I button and check that video as well. So as soon as we have done this, we have this array. Now in this array, using we can say using a map, we can say that there are four elements inside this graph because they all have same root. Okay, and there are two elements inside this disconnected graph as they have same root. By the same root we will basically make a map, and will increment if it has same root. So basically for 0 0 0 for 0 we will create a map and increment it every time we will see another 0. So we will have four elements inside this graph. We will calculate this, that we'll calculate that, and we will have three elements inside this graph because of 5 5 and 5, and we will have one element inside this last graph. So that's how we will calculate that how many elements we are having inside the each graph. Firstly, we have done the same thing from that first algorithm, that we have counted the elements inside the each graph. Okay, now what we are doing here is we are calculating the elements inside the each graph by using union find algorithm. Then that is how we will be doing it. So let us just see the code for union find algorithm, and that will make the things more clear for you. The code for union find algorithm. So in this code, firstly we are iterating through the array of edges and putting it inside our union set. And what this union set function is doing, I will explain that later. So for now you can assume that they are it is just combining all the values in the same graph together. Okay, so that after doing that, what we will be doing is we will be creating an map for the graph size, and we will apply function find on it, and this find function will be doing what it will find out the node root, the node value, as we have seen on whiteboard, for a particular graph. For example, we have a in that example we have 0 1 2 and 3 inside the same graph. In that graph our node was 0. So for the I is equal to 0 it will return 0, 5 is equal to 1 it will return 0, and for 2 and 3 it will also return 0. For 4 and 8 it will return 4, and for 5 6 and 7 it will return 5, and for 9 it will return 9. So basically that will this find function will be doing. So after this find function finds so that will increment in the same position on the and on our map. So we will have 4 against 0, and we will have 2 against 4, and 3 against 5, and we can say 1 against 9. So after that, this formula is similar to the first search only. So we are just have total number of nodes in current graph, and we are just subtracting it by remaining nodes, and doing the similar algorithm as we have done inside our that's first solution. So now what are these union set and find function are doing? So these union set and find function are basically combining all the nodes inside the tree. So how is that these two function are doing? For that, it will be hard to explain in this one video. I have already made a video of 17 minutes on a union find algorithm, only explaining it from very brute force approach, and then to optimizing it to this what we are seeing here. It is most optimized form of union set. So for understanding union set in depth, you can watch watch that video. I have explained each and every function in that, so that will clear you everything about this. So that is it for this video. I hope this had helped you. Thank you so much for watching. Bye bye.